So today we'll be studying digit DP. So I'll be teaching it in a manner that it's really easy for you to comprehend it. And the target audience for this would be beginners and intermediate coders. The only thing I expect you to know is the basic recursion stuff, because in digit DP we are gonna go through the top-down approach, and I expect you to know how recursion works, right? So the explanation would definitely complete. I don't even need to mention that. That's obvious, right? And I'll be discussing a question from Codeforces, and I'll be giving you some questions that would be from Codeforces, from CodeShift, and a lot of other platforms. I'll be giving you those questions as a homework, right? And then we'll discuss that with this recursive approach, how can we build the DP, and how do we save the states. So that would be the motivation. Also, what I'll try to do is that instead of solving a lot of questions, I'll try to give more emphasis on solving a single question and explaining that in detail. Because in the last session, some of you said that it would have been better that if I would have stick to a single question and would have explained it if I would have actually dry run that, right? So that would be the thing. But before starting it, let's just understand what digit DP is. So I'm sure that most of you who actually do DP must have seen some questions, and the questions are like given such constraints, or let's say that a number is valid if it follows these constraints. Now this could be anything, right? This could be that the sum of each digit is actually some number n, the sum of digits is n, or the non-zero digits should be less than equal to x, or anything of this sorts, right? So these are a lot of questions. So this is what they state, and then they tell us that okay, so this is the constraint for a valid number. You have to tell the numbers in a range L to R. So you have to tell the numbers that are valid and are in this particular range. Or sometimes they say that you have to tell the number which is smaller than R, right? So this is actually convertible to this. I'll tell that in a while. Now how is this convertible into this? Before I explain that, any doubts so far? Cool. And also, if you have any doubts, don't hesitate. You can right away ask me, right? Okay. So how is this thing convertible to this? To explain that, what I'll say is that R simply means that I have to find the numbers in the range 0, R, right? Because they are no negative numbers generally in digit DP questions. So I just have to find in the range 0, R. For this, I can say that I'll find the numbers in the range 0, R. That's obvious. And then I'll subtract the numbers in the range 0, L minus 1. So when I'll do this, right? So the way I'll be calculating R would be similar to this, right? And then 0, L minus 1 can be found out by using the same algo. So this way I'll be able to convert the first type of questions to the second type of questions. And this becomes helpful for me. Now, with this knowledge, how can you say, so if I'm giving you a number, right? So let's try to make any number. Now let's say the number is maybe 9, 2, 4, 6, 8, 2, 5, 2, 1, 6, anything, right? And I ask you that you are standing at this particular index, right? You have already built a number from this to this, right? So this is the number, or this is the limit. So this is the limit where in which you have to find the other number, right? Or you have to populate the answer. So you have to tell that how many numbers are there in the range 0 to this number, right? This is the entire number I'm having. So how many numbers are there in this range which follow some constraint, right? So technically you cannot exceed your answer more than this. So you cannot say that I have a number that is greater than this and it still follows the constraint. Yes, there would be numbers, but they are of no use to us because we want to find the elements in this particular range, that is 0 to R, right? What I'll do is that I'm asking you that if you have constructed some number, let's say x, right? So x corresponding to this, let's say, and a y corresponding to this, okay, give me a second. Okay, so a y corresponding to this and a z corresponding to this, right? Now when you have to select, let's say, this particular element and you want it to be an element W, what are your possible choices of W? That would depend on two factors. Now if your x is equal to 9 and your y is equal to 2 and your z is equal to 4, so the number you have already constructed is 924, right? Now in any case you cannot exceed this particular number or the number w by a number that is greater than 6, because if you write, let's say if you write 7 over here, and then there could be then you will have some digits after this as well, so as to replicate this particular array, right? But if you write a 7 over here, then this number would definitely become greater than this number, right? So the only choices you have is from 0 to 6, correct? In what case you could have written a number that is greater than 6 over here? So in case to any element to its left, right? Had you used a lesser number, so let's say for 9 I had actually used a 8, right? Then you had said that okay, for if I'm using a lesser element, then every element to my right can have any value. That makes sense? Guys, I just want this to be a bit interactive. So okay, so if you have any doubts, just speak right away. Cool. So so if I am changing a current element I, right, and I'm making it some other okay, so the value at I was, let's say, 7, right? Now if I make it 6 or less, then that means that this number has actually changed and it has become smaller. Now you have to understand the way we write the numbers, or in any format for that matter. So let's say we actually use decimal format, right? So in decimal format, the numbers are written in such a way that these are the most significant numbers. So let's say the number is 1256, right? Now in this case, this is the most significant bit, right? And this is somewhat less significant. This is even less significant. This is the least significant bit. So if you change or the least significant number, right? Now if you change a number to, right, then it's possible for you, and by that I mean if you change the number to somewhat a lesser value. So if you make a 1, right, so it becomes 1 and a 1. Now for these two elements you can keep any value. So any values from 0 to 9 are possible over here, right? Understandable? Because even if I make the maximum number, that is 1199, even that would be less than 1256. So the overall motivation is that if you change a number to a lesser number, then to its right you can set any number that as you like. Cool. So with that, what I can say is that I'll have to keep a track of that as well, that whether I have used a number that is slightly smaller or not. If I've used that, then I can set any number. So I'll be doing that exactly that. Exactly that is what I'll be doing. So that's all about DigitDP. I know it sounds a bit different, like why we call it DP and all that stuff. I'll explain that as we go on in the question itself. But up till this point, if you don't have any doubt, then DigitDP is technically pretty easy for you, right? When I explain the question, it will become more clear. But up till this point, if you have any small doubt or something like of that sort, you can definitely ask right away. So anyone?
प्रणव,
Yep.
so इस वाले क्वेश्चन में मतलब निकालना क्या था?
No, no,
Like
question. No, this is not a question. This is simply the algorithm. What I'm telling you, right? This is not the question. Question अभी discuss करेंगे.
ठीक है.
Cool. Anyone else?
So good.
Okay, cool. Let's move to the question. So the question states that let's call some positive integer classy. Now they are mentioning over here classy, but it's the same thing as saying that it should follow some constraints, right? If its decimal representation contains no more than 3 non-zero digits, right? So if you have a number, right, it should not contain more than 3 non-zero digits. So for example, 4 is classy, so is 2000, so is 10203. Now in 10203 you have 3 numbers that are non-zero, so that's fine. But if you had one more number that was non-zero over here, then it would not have been classy. For example, 4231, it has 4 non-zero digits. This has 1, 2, and 3 and 4 non-zero digits. It has 1, 2, 3, 4, 5, 6 non-zero digits. These are not classy, right? So you are given a segment L to R. Count the number of classy integers x such that it lies between the range L to R. So that's the question that they have given to us, right? Also, yeah, we'll be given with multiple test cases. So that's what we need to do. The question sounds easy to me, but let's discuss. So the first thing is similar that I told you, that if you're given, if you're asked to check the answer for a particular range, then you can easily say that okay, I'm gonna over here they are asking you to find it in the range L to R, right? So you can say I'm gonna find it for 0 to R, right? And I'm gonna subtract it from 0 to L minus 1. That would give me the valid numbers in the range in the range L to R. But how do I do it? So right over here, this is the code, right? The way I have actually done it. But if I explain you the code, then things might not look that good to you, or you might feel that the question was not that understandable. So I'll try to write it from the scratch itself, so that you are also able to understand how to write the code itself. So I'll remove this. Let's start with the basic code, right? So firstly, I have to take the two inputs, that is L and R. So let me do that. So let's call it L. Let's call the other integer R. Then I'm going to take the two inputs L and R, right? And then what I'm going to do is that I'm going to define a recursive function that is going to give me the answer for each of the input. Okay, so let's define the recursive function. I'll just return 0 so that it doesn't return the error right now, right? And then I'm going to say that my answer is cout recursive of R minus recursive of L minus 1, right? So far so good. I don't think there should be any doubts, but if you have, fire them up. Okay, so one more thing, what I need to do is that I'm actually talking in terms of integers. Now when I'm traversing the entire digit DP, right? So by that I mean that, okay, so when I'm traversing this particular string or this digits, so let's say 9, 8, 7, 6, 5, maybe 8, 2, right? So when I'm traversing this, I know this is the index 0, this is the index 1, 2, 3, okay, 2, 3, then this is 4, 5, 6, right? Now if it's in form of a string, what I can do is that, okay, I need this particular index. So I'll say that for the string S, I need the index IDX. That is easy to do. If it's in the form of number, then it's a bit tricky to do. It's not impossible, but what you need to do is that you need to find, firstly need to divide it by the power of n minus idx, right? And then need to take a modulus with the 10 itself. So this is a bit tricky for me, and so I prefer using this particular method. Now it's up to you, whatever you want to use. So as to like give an example, what I mean is that let's say I want to check that what is the element at the index 1. So if it's like a string that is given to me, I can simply say string of index at 1, right? Or get me the index of 1. If it's in form of a number, then I'll have to do, okay, so you have to divide this particular number divided by, okay, what are the number of digits after this? So 1, 2, 3, 4, 5, right? Number divided by 10 to the power 5. So the number divided by 10 to the power 5 would give it 98. And then you have to take a modulus 10. So you will take a modulus 10 and you'll get an 8. So this particular approach is a bit lengthy. So I prefer to use this particular approach, that convert it into a string and then utilize it further. So that's what I'm going to do over here itself. Okay, so where's the code? Yeah, over here. So let me take two strings, or I can convert it on the go itself. So two string R and two string L minus 1.
right now.
Yep.
Yeah, so in like जो आपने अभी अप्रोच बताई कि पावर से डिवाइड करता है,
हम्म
so और मतलब डिजिट की मतलब जो इंडेक्स है उससे एक इंडेक्स कम
हाँ
माइनस है ना, तो
नहीं नहीं
मतलब
नहीं,
आपने
डिजिट के इंडेक्स से एक कम नहीं. So it's the other way around. So let's say the string is of 6 digits. So okay, give me a second. Okay, so over here the string was of 6 digits, right? When you want to divide it, so let's say you want to find the element at the location 1, right? So what you'll say is that I need to divide it by this particular value. So इधर कितने हैं? 1, 2, 3, 4, 5, right? So over here you are having 5 digits. So you'll say I'll have to divide it by 10 to the power 5.
10 to the power 5 या 2 to the power 5?
10 to the power 5, it's not a binary string, right? It's a decimal representation. Had it been a binary representation, then I would have divided by 2 to the power 5. So if you just want to get, okay, so just to make it easier, let's say this is a string you're having 1, 2, 3, 4, right? Or this is the number you are having. Now if I want to get this particular element, I'll say 1 2 3 4 divided by 100, right? That would give me 12. Then I'll take a modulus 10, that would give me a 2, right? So basically it has to be 10 to the power how many digits are there to your right. Cool.
Yeah.
Cool. Okay, so moving ahead, so this is what I want to do. So over here I'll have to pass it to the function. So let's call it string, and it, since it represents the limit, let's just call it lim itself. So lim gives me the limit. Cool. Now I'll say that I'll also need the index, so let's call it idx. I'll also need the non-zero numbers that are that have already been used. So non-zero. What do I need more? So okay, let's just start with this itself. So I'll say that if your index, let's just display the size as well. So size is equal to lim dot size, right? And if I have already reached the end, so if my index is equal to size, then I can say that okay, I have reached the end itself, and I should be having a value now. Cool enough. So if that's done, then I'll have to return. Okay, return 1. There's one more case. So since you wanted, so the entire motivation of this particular algo was that the number of non-zero digits should be less than equal to 3, right? So I can use that if non-zero is greater than 3, then you need to return a 0, right? Okay, once we have reached there, so what we can say is, okay, so one more thing I like to declare in the variable, that is your current number that you, yeah, some doubt? Okay, cool. So one more thing you need to declare over here, that as we said, then we'll be starting from the left hand itself, right? So let's say your limit was, your limit is, let's say some number like this, 1521, and if the number you are already making, so the current number, let's say that is 1 4, right? Now since you are using a 4 instead of a 5, then for the remaining two numbers you can use any value, because the current number that you have already developed is smaller, right? So that also needs to be sent to the recursive function. Let's call this particular thing as same or smaller. So this would define if your current number is smaller or not. After that, we'll say that if the current number is smaller, then technically you can use any number, right? So you can say that I can use any number. So return, okay, yeah. Okay, firstly, just let's handle one of the cases. So would it be possible? Yeah.
Sorry, can you explain smaller? Like
Cool.
why did you take that?
Okay. So the thing is that if I'm having the limit as 1521, if then I'm starting from the left, right? I'm starting from the left end. So if I've the first number I've taken is 1, and the next number I've taken is 4. Now it doesn't matter what I take to its right, because whatever value I'm gonna take is going to be smaller than this, right? So that's why I've taken smaller, because I want to know that the number I've already constructed to my left, if it's smaller than the limit or not. That's the entire motivation of taking smaller. Make sense? Rotormax, make sense?
Yeah, makes sense. Yeah.
Okay,
Hello,
cool.
am I audible?
Yeah, you're audible. Cool.
Okay.
Okay. So with this, what I'll say is that one of the cases that I can use a 0, right? Now is it always the case that you can use a 0? Yes, it's always that case, because there's no element that is actually smaller than 0, right? So if you are having any number, let's say you have this number, so at any location you can utilize a 0. What would happen is, if in the original number also you were having 0 at the same index, in that case the number wouldn't decrease, but in no case it's gonna increase, right? So since you're expected to generate numbers that are smaller than this, then it's always valid to use a 0. I can say okay, use a 0. So let's define the numbers you're getting as res. So res is equal to, if I'm using a 0, then I'll say that limit is fine, idx plus 1. I'm using a 0 right now. So the non-zero numbers won't be increased, obviously, and either it has to be smaller, right? So if it was smaller before, it's gonna be smaller right now also. But if it was not smaller before, then in one case it can get smaller if the current index was not 0. So if the current index was set to some other value that is non-zero, Now since you're making it 0, so the entire number becomes smaller. So now if it's becoming smaller, I can say if it was smaller earlier, then smaller is fine. If it was not smaller, then it will become small if the limit, if the element at the limit was not equal to 0, right? Then it will become smaller. I hope even that makes sense to you. Okay, let's just put that in brackets. Yep, cool. Then we'll say that if the current index is smaller, okay, so if it's smaller, then do this. If it's not smaller, then do this. Now what is this and that? So if it's smaller, then you can say that I can utilize any number for that, for this particular index. So you can utilize any number from 1 to 9 for this. So you'll say 9 multiplied by, okay, 9 multiplied by recursive call of limit idx, and over here you are using digits from 1 to 9, right? So use digits from 1 to 9. Now since you are using digits from 1 to 9, your non-zero count is going to increase by 1, right? And then your smaller value would actually remain same. So you have already checked that the number is smaller, so you can simply pass 1 over here. It doesn't matter if you pass 1 or smaller. So in the other case, now the number is actually exactly similar. Exactly similar. What do I mean by that is that, let's say if the number that was initially given to you as limit was this, right? And currently you are at I is equal to 2. So considering zero based indexing, you are at the digit 4 right now. So the number you have already formed is 2, 3, right? And now you are at an index 4. Now what are the values that you can use? So you can use any value from 1 to 4. The only thing is that if you are using values from 1 to 3, right? Okay, let's just change it a bit so that it makes, okay, yeah, now it's fine. Okay, 2 and 7 is the number you have already done, and right now you are at the index 2. So you can use any values from 1 to 4, right? But if you use values 1 to 3, then your number is gonna become smaller, because in this case the number is gonna become, let's say 2, 7 followed by a 1, a 2 or a 3, right? So this number is going to be smaller. But if you pass 4, then the number is going to be same. Okay, so how many digits are smaller? So how many digits are lesser? So that would depend on the current limit. So limit idx minus 0. That would give you the number at this particular position. And then I'm gonna subtract 1. Now why I'm subtracting 1? Okay, yeah, I'm gonna subtract 1 because I don't want the numbers. So for example, the number over here was 1. So it will give me 1. So this particular expression would give me 1 itself. But since 1 is the value, if I'm going to take that, I'm not going to make my number smaller. So hence I just want the value 0 to be here. Or let's say the number over here was actually 3. So this particular expression would have given me 3. But I just want to test it for two values, that is 1 and 2, because that are the numbers that are going to make my current number smaller. So I'll say that recursion, okay, then result is plus equal to lesser. And let's just use one more thing. So if lesser is greater than 0, then only there's a point of doing it. Then you say that the current number would be, so I can use any of these numbers now. So whatever numbers would be here in the lesser, I can use any of these numbers, and then the limit would remain same. That's obvious. Also, one good idea whenever you're using recursion is that always mark it with a constant so that you mistakenly don't change it, right? And then you'll keep wondering what's wrong with the solution. So yeah, limit, and then you'll be going to the next index. And then you'll say that, okay, the non-zero is now increasing by 1. Okay, non-zero plus 1. And smaller would be 1. Because now you are using a smaller element. So your smaller is also 1. Okay. Now if you use the greater element. So if your limit index is not equal to 0. Now why I'm checking this? Because for limit index equal to 0, or for the 0th index, considering at the current location, I'd already performed this, right? So I don't want to recompute it, else my answer would become wrong. So I'll say result plus equal to limit idx plus 1. Okay, sorry, recursion of limit, go to the next index, right? And then non-zero would increase by 1. And now it won't be smaller because you are using the same element, so it's not going to be smaller. So I'm just putting a 0 over that. After that, once you have included all of this, you can pass return res. Let's populate the values over here as well. So firstly, you are passing the numbers as a string. Then you'll be passing the current index, that is 0. Then you'll be passing the number of non-zero digits, that is also 0. Then you'll be passing if it's smaller or not. So currently it's not smaller, so pass 0. So it's just okay, 0, 0 and 0. I'll also have to pass the vector. No, cool enough. Let's test it. Okay, it failed. Now why it failed? Okay, let me see that. Okay, so firstly we are sending the result. Okay, if non-zero is greater than 3, then return 0. If size is equal to limit dot size, then okay, size is taken over here.
58th line like recursion like function दोबारा कॉल किया था तो लिखा नहीं.
Oh, right. Thanks, man. Good analysis, by the way. Yeah, these things are quite common when you are doing stuff and you miss out on something, and then out of nowhere you'll not be able to understand why your code is failing. It's still failing. I'll have to analyze why. So if my limit index is not equal to 0, then do this. So you construct the limit. Guys, is it fine if I'm debugging along? Maybe you'll be able to learn that how to debug the stuff, or should I just post the solution and just check it where it's getting wrong? What do you guys want?
Debugging is good.
Yeah.
Okay, cool. Cool. Let me do the debugging then. Okay, so one way of debugging is that, okay, let me see if non-zero was 0, right? Okay, non-zero is set to +1, that's fine. Okay, yeah, over here I had to do an index +1. I'm going to the next index. Hadn't done that. Let's see. Passed, right? So this is how we generally debug. Let's say if it didn't even work right now, what I would have done is that instead of subtracting it, I would have printed both the values, right? So I would have done this, and then I would have checked that where the answer is getting wrong, because I would have received the values that I'm getting for R, then for L. I would have followed that approach. At the end scenario, if nothing worked for me, what I would have done is that I would have actually used the debugging feature, and I would have gone from each recursive call to the other, so as to understand where it's getting wrong. But anyway, since it's working fine, let me try to submit it and let's see if it's working for all the test cases. Okay. Yep. Let's see. Yep, it's working. Okay, so there's one more thing I want to teach. So over here there was no DP, right? But the entire session was on DP. Now that is happening because the constraints are pretty linear. Now you can imagine that even a C problem is having lenient constraints for it. Now had the constraints been more, this would have definitely given you a TLE. So I would like to explain that how do you use DP over here. Now for DP, if you have watched the previous sessions as well, so I commonly say that you need to analyze what are the states. Now what is state? So state is anything that can define your current recursive call, right? Now what are the things that would define your current recursive call? I definitely need the index, so that is obvious, right? I'll need the index. I'll need the number of non-zero values that you have already used, so non-zeros, and I'll need smaller, right? So if it's set to 0, it's set to 1, right? So these are the three things that are actually defining my recursive call. So can I make a DP out of them? Let's look at the constraints. So the constraints over here are that your index is going to be less than or equal to 18, because the number is going from going up till 10 to power 18. So technically the indices are limited to 18 itself, right? So that is fine. So I can make a DP array. Let's call it DP of 18. Let's put it 20, just taking upper bound. So how many values can you have in non-zeros? At most 3. Let's call it 4 itself. Also, what are the two possible values for smaller? Since it's a Boolean variable, you can either have a 0 or 1. So this can be a DP array. Now the way you use DP is that inside your code you firstly set all the values to -1, or a dummy value that you know that wouldn't appear in your answer. So I'll set it to -1. Okay. Over here I'll say that, okay, after all of this basic checks are done, I'll say that if my DP at IDX, and then the second is non-zero, right, and then smaller, if it's not equal to -1, that means I've already computed it. So return my dp idx, then non-zero, then smaller. Cool. And I also want to populate it. So where can I populate it? So I can populate it right over here. Okay, let's just copy paste it. So I need to populate it right over here. Cool. Let's try it again. Okay, so we are getting a weird error. I don't know why. Let's see. Okay, so I was saying if idx non-zero smaller is not equal to -1, then need to return this. Okay, got it. So yeah, a good catch over here as well. The reason I got stuck is because I hadn't practiced this question before the session. So the thing that's happening is that right now you're using this particular function for two numbers, right? And you're using it for r as well as for l, right? But your dp function doesn't know what your l and r is, or what your limit name is. So it was even once it had checked for r, it was using the same values for l itself. So that is something you need to avoid. And how can you avoid it? So you can say l result is equal to this, right? And then you'll say int r result is equal to this. Cool. Then you'll say cout l result minus, okay, r result minus l result, r result minus l result. But before you do the second computation, you need to again set your memory array to 0. Okay, over here, need to set it again. Let's test it now. Okay, have I done the opposite? Yep. Okay, this is l result, this is r result. Cool. L minus 1 again, that would be a problem. Okay, fine. So we got a AC now for this. Let's try to let's just submit it. Let's see if the time complexity actually reduces, the time it takes over there actually reduces, or if it gives us a TLE. Now several times what happens is that your unoptimized solution might not give you a TLE, but when you try to optimize it further, it can give you a TLE owing to the constant constraints or the constant factor. Just wanted to check. Yeah. So over here you can see that the time complexity that was or the time that was being taken for the recursive solution was 312 milliseconds. The time it actually takes to compute for the DP approach is just 31 milliseconds. So that is 90% or more than that faster. So cool. This is what something I wanted to explain. Cool. So reviews. Are there still any doubts, or you want me to explain something more? How was the session overall? Okay, you can share your.
Nice, sir.
Which one?
No problem.
Okay, the code I submitted. You want that? Okay, I'll share that. No worries.
Sir,
Yeah.
suppose you had to keep a constraint on the length of the number in decimal form.
Mm-hmm.
How would you pass that in the state?
So I'll pass it another number. Okay, give me a second. The ID wasn't posted. Give me a second. I'll show you that.
Yeah.
Okay.
A very similar question came in CodeChef starters. It was n plus x, find minimum x such that at least k digits would be there in decimal representation.
Okay, so what you can do is that if you are asked to, have a number of some constant of some constraint that it should have some digit, this many digits or not, then you can add another field over here. So let's say okay was 10, 20, 50. You just pass it over here. That makes sense?
Yeah, but how would you count the length? Since we are building fully the number, I mean, if we talk in the context of that question, the question gave you a number n and asked you to find the minimum x such that n plus x will have at most k distinct digits.
Okay, so given a number, can you give
So
the link to that
in
particular number? So can you give that link to the particular question so that it's more clear?
Uh, don't think I can find it soon enough. It was probably starter 79. You can search.
I probably would have done it then. Let me see. Okay, Coach Chef. Okay, it was starters 79 or what? 79 you're saying, right?
Yeah.
Okay, 79. I hope it was a Div 1 question.
It was in Div 4 too. It was one of the last questions, I think, of Div 4.
Okay. Is it over here? I don't think so.
Let me see. No,
Okay, let's go
I
for Div
don't
4.
really remember which contest.
It's over here.
No,
Okay, so prima facie, the question you're telling, right? I'm not sure if it's a digit DP question or it's just a binary search question. But what I can do is you can post it in the group itself. So you can post it over here in the CP doubts, right? Just make a thread, a new
yeah.
thread. I'll try to answer that.
Okay, sir.
Even yeah.
But in general,
Hmm.
if questions like that appear and we have to apply digit DP,
Okay.
so in that question, if we added x, like if we just did a linear brute force,
Hmm.
the number of digits would increase by adding in n plus x. So, I mean, in n, if you add a positive number x, the number of digits would obviously increase on the MSB side.
It actually depends. The number may or may not increase, right? So let's say your number is 998 and you add one to that, then your number just becomes 999. The count of number does not increases, right?
Yeah, assuming that a number x is sufficiently large for that to happen,
Yep.
um, it will increase from the left hand side. And
Hmm.
since we are doing top down, how would we handle such a thing?
Okay,
The
so
length increase.
gotcha. So the first thing is that I won't advise you to use digit DP, but in general, if you want to check that how many digits are to the left that have already been increased, or if there's some sort of that kind of a constraint, what you can do is that over here, right? Over here, you can pass in another variable. So you can call it digs or whatever you want to call it. And when you know that okay, for this, so let's say I operate something. So operate something that increases the dig, right? So when I'll do the recursive call, I'll just call recursive call with all the parameters, and I'll increase the digs by one or whatever value you want to call it. So you can do it in this fashion. Make sense? So
Oh,
it's
okay, okay.
it's like a general thing I'm telling you because you can extend it to a lot of questions as well, right? So whatever thing is changing and whatever is going to affect your future state, right, or your future recursive call, you have to pass that in the parameters, right? And you have to make sure that DP also calculates it.
Yeah, sure.
Make sense?
Yeah, makes sense.
Cool. Any other questions? Any other questions or advices if I should speed up the session a bit, speed down it a bit, explain the code more properly, maybe dry run it a few times? Any suggestions? Cool. All of you understood the concept?
Yeah.
Okay. I don't know who spoke, but yeah, cool enough. So if you still have any doubts, you can just post it on the group or in the CP doubts, or you can ping me or ping anyone else. People will probably help you out. Cool guys. Thanks a lot. Bye bye.
Bye.